Welcome to lectures on instrumentation in process industries. We are discussing thermal power plant. In that, we have discussed the importance of instrumentation in thermal power plant and in process industries. And we have discussed how the power is generated, the basic principle behind that with a diagram we have discussed. And next, we have taken two important thermal power plant layouts. In that, we have discussed each block and its operation, and we have taken four circuits that that are very important in thermal power plant, and we have explained each circuits in detail. So, in this class, objectives are PI diagram of boiler process and measurement of feed water flow, measurement of level and pressure and temperature of the boiler, and safety measures in boiler control, and interlocks for boiler operation, the turbine trip conditions and working of turbine unit. So the PID diagram of boiler process, first let us consider, and another if the time permits we continue with the measurement of speed and vibration of turbine and working of condenser. So now this is the PID diagram of boiler process. In this, what you have to do is you have learnt the PID diagram procedure, drawing procedure in process control subject. In this, what you have to understand is the machinery and the equipment symbols used in PID. First, you have to consider, and those symbols corresponding to boiler, furnace, and drum, and boiler equipment, those symbols and associated electronic equipment that is used to instrumentation equipment that is used to monitor the physical variables and to control the physical variables. PID depicts the information about the process flow and position and location of the equipment, various equipment, whether it is at field level or whether it is at uh, control panel level, control room. So whether it is accessible to user or not, this information can be shown in PID diagram, and this information will be helpful in analyzing and monitoring different equipment by observing total plant in the control room. And this equipment total plant loop wise, for example, let us consider here the boiler process associated loops we have to consider. So what are the equipments used in the loop, and numbering and following PID diagram drawing procedures, and by taking symbols and names, writing the names, and whether it is located at the field level or at the uh, control panel level, these things, whether it is accessible to user or not, these things we have to uh, follow. So this is the PID diagram, and we have taken in this the equipment symbols corresponding to boiler process, and different loops we have considered, the temperature loop and pressure loop and flow rate loop we have considered, and the equipment that is pressure transducers and controllers and temperature controllers and temperature transmitters. These equipment are drawn in this diagram. You can observe. Okay. Next, let us consider the feed for water flow rate and drum level control, which is very important for the controlling of different parameters in this. By considering the water and steam circuit, here the feed water is supplied into the drum of the boiler. So the circuit we have already discussed, that is, from the condenser the steam is converted into the water and that water is pumped into the boiler drum. So that water flow rate must be measured. So the flow rate of that water can be measured with the equipment here, the water flow measurement. So this water flow, feed water flow measurement is done here, and that measurement value is sent to the control element, that is 3-element control module here. So the water flow rate is measured and it is sent to the control element. And next, not only that single variable, here drum level also, that means what is the level, water level of the drum, boiler drum, that is measured here by this equipment, level measurement equipment. So this level measurement equipment, after measuring the level parameter, that is sent to the 3-element module, control element. And next, another parameter also is to be measured, that is the steam flow. That is, once here in the boiler, this is the boiler drum, in the boiler we have here steam, this is the steam, this steam is flowing towards like this, towards the turbine. Now this steam flow rate is to be measured with the help of steam flow measurement equipment. So this signal is sent to here the control element. That means here 3 parameters are measured. Number 1, feed water flow rate, and drum level, number 2, and steam flow rate, number 3. These are the measurements we have taken and measured them. And after that, these 3 parameter values are sent to the control unit. This is the control unit, 3-element control unit. And according to the control program, what happens is these parameters are analyzed, and finally this control element issues the control signal to the valve, final control element valve. So here the final control element valve, whether some more amount of the water is to be released into the drum, or according to the steam demand, according to the present water flow, according to the water level in the drum, that decision is taken, and accordingly the percentage of the opening or closing of the valve is done according to the manipulating control signal that is issued to the control valve. So this is a feed water and drum level control element. Now here the diagram here shown is, here instead of considering 3 parameters, we have considered a single parameter in this, that is the level, water level in the drum, boiler drum. So that is only the parameter here measured. So the water level, this is the boiler drum, this is the boiler drum. Here you have the level measurement equipment. So it is sent that level value is sent to the level controller. So here, not only that, this based upon the level value, the control signal is issued to the control valve. Here, the feed water is flowing like this. If you observe here, the feed water pumps the water through this valve to throw economizer into the boiler drum. So this is the feed water flow direction. Now in this water is flowing through economizer to increase the efficiency of the plant, and this water flow rate can be regulated with the help of the level measurement, whether the level exceeds a certain set point or not, that is observed by the level equipment. So if it deviates from the set point, then the control signal, that information is sent to level controller. Then the level controller will issue control signal to the valve so that the corresponding opening or closing of the valve is done, so that the feed water flow is regulated, so that it will be supplied to the boiler drum. Here the steam is going to the turbine through superheater. So level element and steam flow element corrects for unmeasured disturbances within the system, such as boiler blowdown, boiler and super tube leaks. So these are the elements which will correct the disturbances. So these are the boiler blowdown and boiler and superheater tube leaks. So these are the disturbances, and these disturbances can be corrected with the help of level element and steam flow element. And feed water flow element, it responds rapidly to variations in feed water demand, either from the steam flow rate, feed forward signal, or feed forward pressure, or flow fluctuations. So here the feed water flow element, it will respond to the variations in feed water demand, so that these flow fluctuations, and pressure and flow steam flow rate fluctuations can be corrected with the help of feed water flow element. In order to achieve optimum control, both steam and feed water flow values should be corrected for density. The three element system that we have discussed provides tighter control for drum level with fluctuating steam load. So, ideal where a system suffers from fluctuating feed water pressure or flow. So, the more sophisticated level of control required, additional input for feed water flow required. So, this is a three element system which will give us the regulation. So, now let us take the measurement of pressure here. The measurement of pressure is, here is the turbine governing system we have. If you consider, this is the turbine governing system. In this, what it does is, it measures the pressure, steam pressure, and uh, turbine speed, and vibrations. These are measured by the governing system, and also it measures the power generation. So now this is the feedback loop here, and steam pressure in the turbine, exhaust turbine, the steam pressure also measured here. It is applied to both steam flow rate, and this steam pressure is also coming to the master pressure control, and the first stage pressure, that is at the turbine location, the first stage pressure is going to generation control, and as well as the steam flow also is fed to the master pressure control. These are the parameters measured and feedback to respective control systems. And after that, after measuring the pressure, throttle pressure, this is called throttle pressure. So the master control, based upon the parameters of this steam flow, present steam flow rate, and pressure of the steam, by considering these two parameters, the master control will issue the control signal to the set point to the another control signal. That is, these two are cascade control systems. Here master process control is there, pressure control is there, and combustion control is there. Uh, these two are the cascade control system. This will act as master, this will act as slave. So this is the set point issued to the combustion control. So the combustion control system will allow the ratio of airflow and fuel flow into the boiler. This is the boiler. This is the boiler. Now the oxygen supply based upon the set point. This is the set point. Oxygen set point should be available at the boiler location. So that the fire, efficient fire will be produced, and the steam is produced, and that is possible with suitable proportion of fuel input and air input into the boiler section, so that those control signals are issued to these two equipments, valves. So here another governing walls. To these governing walls, it will issue the flow of steam pressure according to the steam pressure, and according to the power generation. We have to give appropriate the governing walls will regulate the steam flow into the turbine section. So the turbine, accordingly, the steam flow is converted into the mechanical energy in the turbine, and that mechanical energy is converted into the electrical energy in the generator. So this is the boiler here, and we have measured the throttle pressure, and which is used as a element for the controlling of the input para input raw materials, in which proportion they are allowed to the boiler section. So this is the measurement of pressure. So the throttle pressure is considered a key variable to control because it represents the energy balance between the boiler and the turbine. And when throttle pressure is constant, the boiler is supplying the optimal amount of energy to the turbine. So it is said that the boiler is balanced with the turbine. That means the throttle pressure is suitably maintained at the constant value. Any prolonged deviation from set point will reduce efficiency. So, for example, at a lower throttle pressure, producing the same amount of electrical energy would require increased steam flow and thus an increased boiler firing rate. So that is the pressure measurement. Now let us see the temperature measurement. Here we consider the steam temperature is one of the most challenging control loops in a power plant boiler because it is highly non-linear and has a long dead time and time lag. That is, these are the problems associated with the steam temperature. So adding to the challenge, steam temperature is affected by boiler load, rate of change of boiler load, airflow rate, and a combination of burners in service, and the amount of soot on the boiler tubes. So these are the challenges, additional parameters that are affecting the measurement of steam temperature and control. After separation from the boiler water in the drum, the steam is superheated to improve the thermal efficiency of the boiler drum and turbine unit. So the efficiency can be improved with the superheated steam. So the steam temperature is normally controlled by spraying water into the steam between the first and second stage superheater to cool it down appropriately to maintain certain temperature. And water injection is done in a device called an attemperator or desuperheater. So the two names are used for this, for those devices, attemperator and desuperheater. The spray water comes from either an intermediate stage of the boiler feed water pump or from the pump discharge. So these are the possible water inlets into the attemperator. So this is the arrangement for the steam temperature regulation. Here, if you consider, this is the boiler, this is the boiler, and the steam is coming out of the boiler, and it is going through a first stage superheater. This is the first stage superheater which will increase the temperature of the steam, and next it is going to desuperheater. This is the attemperator, this is the attemperator desuperheater, and from that it is going to, the steam is going to second stage superheater, and then it is going to high pressure turbine unit. So here the temperature of the steam is measured by this unit instrumentation device, that is the main steam temperature measurement and transmit, and the temperature of the steam is measured by this device, and the corresponding electrical signal is sent to the temperature control unit. So the temperature control unit, based upon the present value of the temperature and the main steam temperature set point, so according to the set point value and the present temperature, if there is any deviation, it will issue control signal, electrical control signal to the valve. So this is the spray water control valve. So the spray water is coming into the desuperheater like this. This is the direction. The feed water, the spray water is coming like this. So this spray water is regulated. This spray water is regulated by this valve and this loop. This is the loop that will regulate the spray water. So appropriate amount of the spray water is sprinkled upon this steam. So that appropriate temperature value is to be maintained uh, by maintaining minimum deviation from the set point. So this is the temperature, steam temperature measurement and control. So now let us consider the safety measures in boiler control. So here the boiler is a very hazardous equipment. We have to take a certain precautions, safety measures while accessing the boiler or maintaining the boiler. So the first one is never fail to anticipate emergencies. Emergency may come at any time. Do not wait until something happens to start thinking. So that is the first thing you have to keep in mind. And always study every conceivable emergency and know exactly what moves to make. And never start work in a strange plant without tracing every pipeline and learning the location and the purpose of every wall. Know your job. That is the important thing. So unknowingly, you should not move here and there. Whenever you join the plant first time, always you observe every pipeline, every equipment, and where it is located, how it operates, what are the causes of danger associated with such equipment. You have to know. Always proceed to proper valves or switches rapidly but without confusion in time of emergency. You can think better walking than running. With confusion, if you run, nothing will happen. With better understanding, if you even though you walk, you will achieve good results. That is the thing you have to remember. Never allow sediment to accumulate in gauge glass or water column connections. A false water level may fool you and make you sorry. Always blow out each gauge glass and water column connection at least once a day. Forming good habits may mean longer life for you. Never give verbal orders for important operations or report such operations verbally with no record. Have something to back you up when needed. So without proper information, without knowing the things properly, you can't go ahead. Always accompany orders for important operations with a written memorandum. Use a logbook, record every important fact or unusual occurrence in your site. And never light a fire under a boiler without a double check on the water level. Many boilers have been ruined and many jobs lost this way. So, this is the important factor. Always have at least one gauge of water before lighting off. The level should be checked with the gauge cocks. You will not be fired for being too careful. Never light a fire under boiler without checking all valves. Why take a chance? Always be sure blow down valves are closed and proper vents, water column valves, and pressure gauge cock are open. Never open a valve under pressure quickly. So never open a valve under pressure quickly. The sudden change in pressure or resulting water hammer may cause piping failure. Always use the bypass if one is provided. Crack the wall from its seat slightly and await pressure equalization, then open it slowly. Never cuts a boiler in on the line you unless its pressure is within a few pounds of header pressure. Sudden stretching of a boiler under pressure is dangerous. Always watch the steam gauge closely and be prepared to cut the boiler in, opening the stop valve only when the pressure are nearly equal. Never bring a boiler up to pressure without trying the safety valve. A boiler with its safety valve stuck is nearly as safe as playing with dynamite. Always lift the valve from its seat by the hand lever when the pressure reaches about three quarters of popping pressure. So never take it for granted that the safety valves are in proper condition. So the power plant is no place for guesswork. Always raise the valve from its seat with the lifting level periodically while the boiler is under pressure. Test by raising to popping pressure at least once per year. Never increase the setting of a safety valve without authority. Serious accidents have occurred from failure to observe this rule. Always consult an authorized boiler inspector and accept his or her commands and accept his recommendations before increasing the safety valve pressure setting. Never change adjustments of a safety valve more than 10%. Proper operation depends on the proper spring. Always have the valve fitted with a new spring and restamped by the manufacturer for changes over 10%. Never tighten a nut, bolt, or pipe thread under steam or air pressure. Many have died doing this. So, this is an important factor. You should not work under steam or air pressure. These are the dangerous locations. Always play safe on this road. The one that is going to break does not have a special warning sign. Never strike any object under steam or air. Always play safe on this road. You cannot tell pressure. This is another sure path to the undertaker, which straw might break the camel's back. Let us consider boiler interlock. In this, boiler interlock isn't a physical control device. Instead, it describes how the system has been wired in. It's a wiring arrangement that prevents your boiler from heating your home when there is no need for it. For example, if the temperature that you set on the thermostat has been reached, so without interlock, the boiler would be on continuously. So when the boiler is running continuously, then the boiler steam temperature increases. So without regulation, without interlock, it may be becoming hazardous. So there are different kinds of interlocks we have in the power plant. That is a purge interlock. Next, low air flow interlock or fan interlock. Next, low fuel supply interlock. Next, low loss flame interlock. Next, fan interlock. Next, low water interlock optional. High combustibles interlock optional. So these are the different interlocks can be used in the power plant. So the purge interlock prevents fuel from being admitted to an unfired furnace until the furnace has been thoroughly air purged. So this is the purge interlock purpose. Next, low air flow interlock or fan interlock. So the fuel is shut off upon loss of air flow or combustion air fan or blower. And the low fuel supply interlock. Fuel is shut off upon loss or fuel supply that would otherwise result in unstable flame conditions. Loss flame interlock. All fuel is shut off upon loss of flame in the furnace, or fuel to an individual burner is shut off upon loss of flame to that burner. Next, fan interlock stops forced draft upon loss of induced draft fan. Next, low water interlock shuts off fuel on low water level in boiler drum. High combustibles interlock. This will shut off fuel on highly combustible content in the flue gases. So these are the various conditions how the interlock will stop the flow of fuel into the furnace. So here turbine trip conditions. So a turbine trip is the emergency shutdown of a power generation turbine due to unexpected events. So due to the number of issues that may cause a trip, they are relatively common events. Although it can occur on any such turbine, the term is most often seen in the field of nuclear power. Many events can cause a turbine trip, including turbine overspeed condition, where the turbine accelerates over its desired speed, typically by 110%. Another important trip condition is low vacuum in the secondary cooling loop or condenser. This is another case. And lubrication failure for any number of reasons. If the lubrication fails, then only the turbine should be tripped. Vibrations due to any number of issues. So because of the vibrations, the problem may arise so that unstable fluctuations in the speed must be avoided, so the turbine must be tripped. In order to trip the turbine, inlet steam has to be removed from the feed. So this is normally accomplished with dump valves and reroute the feed steam from the turbine inlet directly into the condenser. That is the point. Instead of directing towards the turbine, it will be rerouted into the condenser. So that is the turbine tip conditions. What is a steam turbine? So let us consider the steam turbine here. It is a kind of heat engine machine in which steam's heat energy is converted to mechanical energy. So there is no piston rod, flywheel or slide valves attached to the turbine. So maintenance is quite easy. So it consists of a rotor and a set of rotating blades which are attached to a shaft, and the shaft is placed in the middle of the rotor. So this is the important construction. An electric generator known as a steam turbine generator is connected to the rotor shaft. That means the same shaft is rotor shaft is holding both turbine and generator. So the turbine generator collects the mechanical energy from the shaft and converts it into electrical energy. The steam turbine generator also improves the turbine efficiency. As the turbine rotates, the shaft also rotates. Hence, the turbine generator also rotates so that the power is produced. Here there are two types of turbines: impulse turbine and reaction turbine. Observe here the physical construction. If you observe, the impulse turbine and the reaction turbine both are having rotor. You see, this is the rotor, and next, if you observe, the moving buckets, these are for this turbine, you observe moving buckets and fixed nozzles. You see, moving buckets are having fixed nozzles, fixed nozzles. But here, if for this turbine, the fluctuating nozzles you can observe. These are the fluctuating nozzles. That is the difference. You see the construction? The fluctuating nozzle is the steam is flowing like this. You see the steam path like this. This is the fluctuating type nozzle. And for the fixed nozzle, the moving buckets type, if you observe, through the fixed nozzle, the steam is striking the here moving buckets, and it is flowing like this. You see, like this. So that is the direction. And if you observe here, the pressure as the for this turbine, as the velocity increases, that is like this, and the pressure comes down. Here the velocity is increasing, the pressure drops down like this. So these are the two types of turbines we have. And observe here, this is the turbine physical construction, how the shaft is there. See, this is the shaft. Internally you have the shaft, and you see the blades. So this is the big structure of turbine you have. Observe here the more another figure. One, so here one blade is taken here. So this is the blade. So one of the blade is highlighted here. This is the one, the structure of the blade in the turbine. See another pic of turbine. So the working principle of a steam turbine. A high velocity steam is coming from the nozzles and it strikes the rotating blades, which are fitted on a disc mounted on a shaft. This high velocity steam produces dynamic pressure on the blades, in which blades and shaft both start to rotate in the same direction. So the conversion of kinetic energy does mechanical work to the rotor blades, and the rotor is connected to a steam turbine generator, and the turbine generator collects mechanical energy from the rotor and converts into electrical energy. So this is the turbine working. So in the next we will discuss governing system uh, in the next class, but today in this class we have discussed uh, turbine working principles and boiler control and PI diagram of boiler and feed water regulation, temperature measurement, steam temperature measurement and pressure measurement we have taken. And in the steam temperature we have discussed attemperators or desuperators which will control the steam temperature. So with this we conclude our lesson. Thank you.